Dentinogenesis is the process of formation of dentine. It starts off with the deposition of predentine, which is an unmineralized organic matrix comprising majorly of collagen and a tiny fraction of non-collagenous proteins. This is followed by mineralization of the organic matrix, thus forming dentine. The organic matrix or proteins comprise mainly type 1 collagen with fraction of type 3 and type 5 collagen. Dentine phosphoprotein, dentine siloprotein, dentine silophosphoprotein, osteonectin, osteopontin, and GLA protein make up for non-collagenous proteins. Together, they make up around 20% of dentine and along with water comprise 30% of dentine. The rest of the dentine is made of inorganic material composed of hydroxyapatite. Formation of dentine begins in the Bell stage when the undifferentiated dental papilla cells near the inner enamel epithelium start to differentiate into odontoblasts due to the influence of the overlying epithelium. The inner enamel epithelium in the early Bell stage, before differentiating into ameloblasts, secrete growth factors and signaling molecules like transforming growth factor and bone morphogenetic proteins which help in differentiation of dental papilla cells to pre-odontoblasts. Pre-odontoblasts then gradually become bigger in size, elongate to become odontoblasts, and develop numerous organelles like endoplasmic reticulum, ribosomes, and Golgi complex necessary for protein secretion. The nucleus becomes polarized and shifts to a position away from the inner enamel epithelium. Before we get to how dentine secretion happens, let's understand that dentine has two compartments, the mantle dentine and the circumpulpal dentine. Mantle dentine is the first formed dentine, which is around 15 to 20 mm thick and is confined to the upper layers near the enamel. The rest of the dentine is called circumpulpal dentine. Now, odontoblasts, once fully differentiated, start to secrete collagen molecules and non-collagenous proteins in the extracellular region towards the inner enamel epithelium. The initial mantle dentine matrix comprises of mainly type 1 collagen and partly of von Kopff's fibers comprising type 3 collagen. After the odontoblast secretes the initial mantle dentine matrix, it develops a process called the odontoblastic process, which extends into the extracellular matrix. Now, this odontoblastic process, otherwise called Toombs fiber, keeps elongating as more organic matrix is deposited and odontoblast moves towards the pulp. Odontoblastic processes are finally embedded in dentinal tubules in the fully formed dentine. Hence, the mantle dentine does not have dentinal tubules. Now, do not get confused with the Toombs process and the Toombs fiber. Toombs process is the distal extension of an ameloblast that is responsible for secretion of rod and interrod enamel, whereas the Toombs fiber is the odontoblastic process of the odontoblast present within the dentinal tubules in the fully formed dentine. So once organic matrix is secreted, the matrix is mineralized, but only up to a point where there is a small layer of unmineralized organic matrix between the odontoblast cell bodies and the mineralized portion. This unmineralized matrix layer is called predentine and is always present throughout dentinogenesis between the odontoblast cell body and the mineralized portion of dentine. Predentine is around 15 to 20 microns in thickness. Now, once the mantle dentine matrix is secreted and mineralized, the circumpulpal dentine matrix starts to be deposited. Circumpulpal dentine matrix consists mainly of type 1 collagen, non-collagenous proteins, and proteoglycans. The matrix deposition is hypothesized to happen from 2 points. One is immediately near the cell bodies, and this layer of predentine consists of collagen and proteoglycans. The non-collagenous proteins, however, are transported via the odontoblastic processes and deposited in the mineralization front, that is, in the predentine immediately below the mineralized dentine. Thus, circumpulpal dentine has two compartments, the predentine and the mineralized dentine. The predentine is 15 to 20 microns in thickness, with one portion of predentine immediately adjacent to the odontoblast cell bodies, having only collagen and proteoglycans. And the other portion of predentine is immediately below the mineralized dentine and is called the mineralization front and comprises of non-collagenous proteins in addition to collagen and proteoglycans. Mineralization starts from the mantle dentine matrix and proceeds towards the circumpulpal dentine. When the odontoblast secretes the mantle dentine matrix, it buds off many membrane-bound vesicles called matrix vesicles that come to lie in the matrix below the inner enamel epithelium. Now these vesicles contain enzymes like alkaline phosphatase, metalloproteinase, and other proteins that can bind calcium and inorganic phosphate and initiate hydroxyapatite crystal growth. The seed of growth is initiated within the vesicles, then rupture from the vesicles and are deposited in the matrix. These growing crystals further fuse with adjacent crystals and mineralize the entire matrix. As mineralization proceeds to the circumpulpal dentine matrix, there are no matrix vesicles found. What rather happens is calcium is transported from the subodontoblastic area to the mineralization front, either through the odontoblasts or in between odontoblasts. Alkaline phosphatase activity and calcium ATPase activity have been reported within the odontoblasts, which may facilitate the transport of mineral ions to the mineralization front. Now, once in the mineralization front, the non-collagenous proteins deposited here help in mineralization of dentine. Now, mineralization may be globular or linear. In the mantle dentine matrix, collagen may be arranged in whorls or in a concentric manner. Now, this may result in globules or concentric masses of calcification, which may enlarge and fuse with adjacent globules. Hence, globular calcification is mostly found in the mantle dentine, and circumpulpal dentine may have both globular and linear calcification. Linear calcification is when the calcification or mineralization front appears uniform.